When you have perpendicular lines, the important thing to keep in mind is that they intersect, making a 90-degree angle. Okay, they don't just intersect, however, they must intersect to form a 90-degree angle. Basically, if you could imagine it being one of those perfect T's, right? Whether it's a nice T like that or for some reason it's at an angle, it would be perpendicular. Now, in order for you to have perpendicular equations, there's a few things that must be met. Obviously, they need to be on the same plane, okay? Um, and when I say they're on the same plane, I am referring to that they're on the same, I guess, a surface, okay? When we're talking about the lines themselves, okay? For example, on this piece of paper, these two right here, they happen to be perpendicular, okay? Even if you're looking at it at a different angle, okay? If you were looking at this box of crayons here, this and this, right? I mean, they're also perpendicular. This line right here and this line right here, they're perpendicular. And you might be like, sir, this line is not on the same plane as this, but they are. You think of it like this. They're on the same surface. This line and this line on the same plane make a 90-degree angle. But anyways, they have to be on the same plane. They must intersect, forming a right angle. And that's what that means, okay? And now when it comes to the actual equations, the slopes, so whereas when the equations are parallel, their slopes are the same. When they're perpendicular, obviously they cannot be the same. They have to be different. But if the equations are not the same, they're pretty much guaranteed that they're going to intersect. But they will only make a 90 if the following is met. So the slopes must be the negative reciprocal, okay? Negative reciprocal. I'm going to go ahead and write the term here, but negative reciprocal, okay, of each other. And basically, if you ask me, all that happens with the slopes is that they flip and change sign. Okay, I mean, that's literally what happens. They flip and change signs. I'm going to give you a few examples here. Let's say you had the equation y is equal to 3 over 2x plus 7. And you needed to find out which of the following was perpendicular to it. Okay? Which of the following is, remember, they could always give you words or they could give you symbols, is perpendicular to. And your options were y is equal to 3 over 2x plus 5. Y is equal to 2 over 3x plus 5. Y is equal to negative 3 over 2x plus 5. And y is equal to negative 2 over 3x plus 5. Please keep in mind that I decided to keep these the same because these won't make a difference at all when it comes to whether it's going to be parallel or perpendicular. Remember, these are just vertical shifts. That's all they do. The actual angle of the line is determined by the slope. So right now, if we just look at this, our current slope, it already looks like the way we want. Our current slope is 3 over 2. For it to be perpendicular, it must flip and change sign. Remember, if it's exactly the same, it's considered to be parallel. That's exactly the same. That is automatically out. Again, it has to flip and change sign. So if right now it was positive, it has to be negative in the end. So this is automatically out. So now we're just looking for the one where it flipped and changed sign. So if this is 3 over 2, it's going to flip and change sign. So it's going to become 2 over 3. It used to be positive. Now it's negative. So look for that one. Oh, it's right here. That's all it is. So let me go ahead and show you this on the actual graph so you guys can check that out. So let's see. Let's delete that one. So the original one was was 3 over 2x plus 7. And we're saying that the new one, for it to be perpendicular, has to be negative 2 over 3x, and we're putting in that plus 5. So again, we have this 3 over 2. Okay, and I know it doesn't look like it just by looking at it because the scale. So let's go ahead and just look at the scales here really quick. Window settings, and let's just do 1010, and just to keep everything proportional, 10 10 auto, okay. And so we have 3 over 2. Oh, okay. So I was getting a little scared here, but look at what happened. I forgot to put the x. All right, there you go. I knew something didn't look right. So 3 over 2 and negative 2 over 3. You see the x's. They're there. And there's your angle. Okay. Again, that's pretty much it. That's what they're going to look like. I don't like how right now, as I'm looking at my figure here, it's not looking like what I would want it to look like. So I'm going to go ahead and open up a calculator really quick on the internet and see if that one provides us with a better picture, better diagram. So y is equal to 3 over 2x plus 7. And the other one is y is equal to negative 2 over 3x plus 5. Okay. So right here, I think this is a better picture. I don't know if you can tell. Let me see if I could zoom in. It's much better. This now looks like a T. Okay, it's a little bit clearer than the other picture. And just to show you guys that it matters not, I could have put y is equal to negative 2 over 3x plus 3 instead, and you still see the same thing. Okay, they're still perpendicular. Now again, guys, your equations, when it's in y is equal to mx plus b, it's perfect, but there will be times when they give you an equation that's in standard form or in just something else. Okay, so what if they said, what is equation perpendicular to 4x plus 5y is equal to 10. Okay, and they give you options, right? Let's say answer choice A was let's say it was y was equal to 4 over 5x plus 2. Y is equal to negative 4 over 5x plus 2. Y is equal to 5 over 4x plus 2. And y is equal to 5 over 4, but negative x plus 2. Obviously, if you had a graph, it'd be very straightforward. But let's just focus on the equation. We're going to have to do the same thing. We're going to have to make it look like this. We move the x to the other side. We divide everything by 5. So this is my current slope right now. This is what m is right now. But keep in mind that they want it perpendicular. So if they want it perpendicular, this has to flip and change sign. So if I had negative 4 over 5, it has to flip and change sign. It was negative, now it's positive. So I'm looking for the one that says positive 5 over 4 on the x. That's my answer. So again, guys, pretty straightforward when it comes to the actual algebra. But what you need to remember is that if they ever tell you that they want something perpendicular, you need to get the slope, whatever it may be, and you just got to flip it and change the sign. Okay? And this will help you ultimately do these problems over here. So we have some problems here that I'm asking you guys to work on. And basically, if we go to week 3, this is where the stuff for this week, where you'll be seeing these perpendicular equations. So again, you see parallel, 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 perpendicular, right? And some of them look slightly different, but again, just make them look like y is equal to, and then you'll be fine. So let's look at one here really quick, because these go into the next formula, but I just want to go straight to the point here. Parallel, perpendicular. All right. So we look at number 1 here right away, just by looking at number 1. Okay. They're giving you the equation 14x plus 21y is equal to 9. So again, at some point, you're going to have to do that work of moving things around. So 21y is equal to negative 14x plus 9. We're going to divide everything by 21. Now, I want to remind you guys that when you won't get a nice perfect number, just leave it like that and try to simplify. They're both divisible by 7s, so we can say this becomes negative 2 over 3x. Here, they're both divisible by 3s, so we could say it becomes, there 3 goes into this 3 times and 7 times, plus 3 over 7. But the important thing here is looking at this right here. This is our slope. So the equation of our answer is going to have, well, they want perpendicular. So right now we have this negative 2 over 3. It's going to become positive 3 over 2. So this is the slope that we're going to be looking for. And I know here you're going to have to do this basic work on all of them, but you're going to be looking for the one that has a slope of 3 over 2. So just keep that in mind. Same thing here, just by looking at this, look, this line is negative. They want perpendicular, so the equation has to be something positive. So right off the bat, the last 2 are out, and it's one of these 2. So again, guys, just keep that in mind, okay? And imagine it. They're telling you it has to pass through point P, and you know it has to form a T of some kind. Would you expect it to go over here to the 8, or would you expect it to go over here to the positive 8? Right, like that, you get your answers right away. All right, guys, and again, if you have any questions, just reach out.